Welcome to another lesson on similarity. I'm just picking a small section on similarity. Basics, linear scale factor, compare corresponding lengths of image and object. Area scale factor, compare the areas of image and object. And the volume scale factor, volume of image over volume of object. This is the basic. There is also very important relationships between the three quantities. I can get linear scale factor from the square root of area scale factor. I can also get linear scale factor, okay? I can get linear scale factor from cube root of volume scale factor. That's basic. Now, the mass in this topic is assumed to be volume, okay? Anytime you are given like 50 grams, you can take it to be 50 cubic centimeters. That can be proved. We can show that. We leave that for next day. I want us to check on this lower part, okay? Let us focus down there. Good. If a frustum is given, anytime you are given a frustum, please complete the frustum to form two figures. So an example, this is my frustum. I'm given that. Then I have to complete it. Extend the lines until they meet. There. Now, you can see I have two cones. There's that small one, the one with dots, and there is now this big one. Okay, that is what I meant. And we have to compare corresponding. So I can be given big radius over small radius. That can be equal to capital height over small height. That can be equal to big slanting height over small slanting height. These are three I have shown. At any given point, you must have two. So this will drive you to get a length which will be used for further computation. Otherwise, if you don't complete, you lose the meaning of similarity. When we say similar, there are two things we compare, at least two things. So we complete to give us that comparison. So the part that is missing is just a trick. So what do? Get the corresponding sides compared. At any point, you will have two pairs, okay? And in those two pairs, there will be only one thing missing. The questions that follow are like volume of pyramid, which you know it is in the table. A third times base area times height. They are in the table. You don't need to cram that. Volume of a cone is a third pi r squared h. A third times pi times r squared times h. So sometimes you can be given even diameter. So big D for big diameter, small d for small diameter. So any of these things will push you through. Next, we are going to have now a question to see how to implement what we have learned briefly. Thank you very much. We meet next lesson. We do one question. We see if our skills are on the right track.